Good evening, everyone. This video is a short demonstration of the course project for the cloud computing course. The course project topic that has been chosen is personal assistant as a service. So in this case, we are utilizing the popular platform OpenClaw and wrapping it around the context of a personal assistant. And it will be short named with the abbreviation OCAS, which stands for OpenClaw as a service. In this case, OpenClaw is hosted as a Docker stack where all the different capabilities of Docker is utilized for hosting OpenClaw and all its dependencies. OpenClaw is all the different features and capabilities are exposed via RESTful API using a Python fast API wrapper, and through which external services can talk to the OpenClaw service, which in turn talks to a locally hosted Quen 3.59b model, which is running on a remote system. All of which are connected through a Tailscale VPN network, such that the remote system is able to talk to this Docker container. So as you can see in this case, there is a run script. There's a bash script called run, which is created for the ease of the purpose of starting up the Docker stack easily. Instead of running the Docker commands directly, there are some aliases set up. So in this case, it can be seen that running the start argument or passing the start argument to the run script, the script will actually start building the container and start it up. So in this case, all the different Docker file actions are completed one by one. All the relevant images are pulled and all the different containers are started. So in this case, there's a Tailscale container which enables the communication between the remote PC running the locally hosted Ollama model, Quen model through Ollama, and the actual OpenClaw image. Then OpenClaw init service, which is basically just the configuration for OpenClaw injected at runtime as a hot swappable configuration. So whenever a change is needed to OpenClaw's capabilities, it can be done on the fly without stopping the container. Then last but not the least, there is also the API, fast API wrapper, which is exposing all of OpenClaw's features to the outside world and to external agents. So in this case, the run script has actually completed, and you can see that OpenClaw agent is actually ready and ready for accepting commands. So in this particular video, we'll be demonstrating one of the capability of the API, one of the capability of OpenClaw exposed via the fast API endpoint. So these are all the different capabilities of OpenClaw. So in this case, we have set up a health check endpoint and an agent status endpoint. These are made available such that because there are multiple moving parts for this Docker stack, this is to ensure that all the different systems are up and running before any different kinds of interactions are done. So in the event that this system is being uh, attached or connected to another service, that service can first query the health check endpoint to verify all the services are up and running before making subsequent calls. Apart from this, there are tasks and schedules. So in this case, this OpenClaw is considered under the context of a personal assistant who is able to uh, remember, create, remember, and update different tasks that you need to complete, sort of like a smart to-do list, as well as remember any important schedules or events that needs to be reminded for you as needed. So all these tasks can be added to the a small locally running SQLite database where all the different tasks and schedules are stored. And these endpoints various endpoints, get, post, put, delete, and patch endpoints are made available such that basic CRUD operations can be performed on both the task and schedule endpoints. What makes the power personal assistant smart are the special capabilities where the OpenClaw is given access to fetch different multiple tools from the internet. So in this case, OpenClaw is given access to Mastodon API for fetching social media information, and it also has access to GitHub API to perform certain actions, as well as research on particular topics and even give a code review for codes that is submitted to OpenClaw. It can help you draft the email and change the tone of the content that are passed to it. It can summarize a particular topic. Once a big chunk of information is passed over to OpenClaw through the API, it will synthesize using the LLM, and it will give a summarized version as a return. Yeah, so in this particular demo, we'll be looking into the uh, code generation endpoint, specifically speaking, the GitHub wipe generate. So in this case, we are required to pass certain payloads to the payloads to OpenClaw to this to make sure what commands does OpenClaw need to create the different uh, create the create the application that we want to achieve purely from a simple human language model. So in this case, a plain GitHub repo has been created. So as you can see, there are no files in this GitHub repo except for a README file, which just says that it's a simple calculator built with HTML, CSS, and JavaScript. The only special permission given on this repository is that GitHub Pages has been enabled on this repo, such that in the event that there is a website file already hosted in this repo, it is automatically translated into a website, allowing it to run the script real time and showing the updates in real time. So in this case, I am passing a particular payload where I'm passing the details of this particular repo. So this is the username, and this is the repo that the user has, which is being passed here. Then this is the description of what I want OpenClaw to be generated for me. So in this case, I'm giving a payload of a fully working calculator with HTML, CSS, and JavaScript as a single index.html file. And basic calculator functions and digits are to be shown. And two flags are actually set here. So one is push to repo, which is set to true, and enable pages, which is set to true. What this enables is once the code is generated by the LLM, it will be automatically uploaded into this endpoint, this repository, and due to GitHub Pages being enabled in the background, it will be translated into a website by GitHub itself. So in this case, I'll execute this command, and behind the scenes currently, this is being passed on to the OpenClaw agent, which is actually talking to the LLM model and generating codes on behalf. So apart from just a startup, the run bash script actually also fetches the logs of what the LLM is doing. So in this case, you can see that the OpenClaw LLM agent is actually prompting the Quen model saying that you are a software engineer. A user has requested the following: a fully working calculator with HTML, CSS, and JS. This is exactly what was passed as the payload through the API, and you can see that the LLM has actually responded with the website code, and it is being passed over to the agent, then once the agent finishes it, it is actually sending the updated information, and OpenClaw is invoking the tool call, which is web fetch, and it is actually checking against the GitHub API to make sure whether the file exists before it makes a push. Then after which you can see that there is a GitHub push command that succeeded. So in this case, if you go back to the GitHub repository and refresh the page, you can see that a new index.html website file has been pushed immediately once the code is generated, and it has been built as well. So if you go back to the API, there is actually a response with uh, the entire generated code, as well as where this feature was pushed to, what is the repo link, and what is the exact link to the file that was updated, as well as the website link to access it. So if this website is accessed here, you can see that this is actually pulling straight from this repo, and this file is hosted live on this website. And as you can see, it's a fully working calculator, purely from natural language feature request through the API, which OpenClaw managed to invoke its own internal tools along with the LLM model to create a fully functional website by itself. Yeah. Yep, that's all for the short demo. Thank you.